bell ding going off in your head and go like, oh, there's only one column called I. Because we have two subroutines, they're both using the same variable as a counter. So that should be the first indicator that, oh, maybe something is not right because we're using the same variable in two different contexts. But the trace will actually make it very clear what is going wrong with this, what will go wrong with this code. So we'll go ahead and take a look at how this program is going to go wrong. Line 17 is the first line that is outside of a subroutine, so we'll start with that line. Doesn't do much. All it does is to initialize x to 11. Then we go to line 18. Line 18 is invoking add 6. So we have to allocate a new column for our return line number. The return line number is going to be post because line 18 is the last line of the program already. There are no lines following it. And after that, we will go into the subroutine and actually start on the first line of the subroutine, which is going to be line 10. Line 10 is right here. It initializes I to 0. And then we go to line 11, which is evaluating the condition of the loop. I is less than 2 is true because 0 is less than 2. Then we go into the loop. We go to line 12. We invoke subroutine add 3. Which means we have to allocate another column for our new return line number. The invocation is on line 12, which means by the time it is done, it has to continue execution on line 13. Okay, so that's not a big deal. Oh, I almost forgot. And after I saved where to return to, I can go ahead and continue execution in the subroutine, which is going to start with line 2. Are we doing okay so far? Okay, here we are at line 2. What does line 2 do? It initializes I again. Now this is the second ring or the second ding that you should hear in your head because, hey, we just initialized it a few lines ago. And now we are reinitializing exactly the same variable. Now it may not look like there's trouble because we are reinitializing it to 0. So it seems like this is completely harmless. Then we go to line 3. Line 3 is checking I is less than 3. It is true. We go to line 4, add 1 to x. X goes from 11 to 12. Then we move on to line 5, which is adding 1 to I. I goes from 0 to 1. Then we go back to line 3. I is less than 3 is true. And I need to split the screen so we can see. Then we go back to line 4, which is adding 1 to x. X goes from 12 to 13. We go to line 5, which adds 1 to I. I goes from 1 to 2. Go back to line 3. I is less than 3 is true because 2 is less than 3. Then we go back to line 4, we add 1 to x. X goes from 13 to 14. We go to line 5, which adds 1 to I. I goes from 2 to 3. We go back to line 3. I is less than 3 is finally false. Then we get out of the loop. We end up on line 7. Line 7 looks up the most recently created return line number, which is on column F. Column F tells me I have to go back to line 13. And then we have to deallocate column F. And now we're back to line 13. What do we do on line 13? We increase I by 1. And now I is already 3. You add 1 to 3, it becomes 4. Oh, something is not right because when we go back to the beginning of this loop on line 11, I is less than 2 is false. It was supposed to go through that twice. It only went through it once. Okay? Because you can see that our variable x only went all the way up to 14 and not 17. It missed one iteration in the subroutine add 6. Okay? So we'll just go ahead and finish this whole thing. We go from line 11 to line 15. Line 15 is going to deallocate this column after remembering that we have to go back to post and the trace is all done. In other words, in this case, the program does not crash. The program does not crash because there's nothing wrong with it that will cause it to crash, but nonetheless, it does not behave correctly. So I will name this file global variables are evil, because that is exactly the point of this sample program. Why do you think this program does not behave as what we thought it should behave?
Because that I is actually different from the first I.
It's because it is not different. It is because they are the same. Yep. They should be different, but they are the same. Okay, very good. That's good observation. How do we fix this problem? Quick and easy way, name the other variable j, right? Okay. In other words, one quick way to fix it is to go to line 10. Okay, we can go to line 10, go to line 11, go to line 13, and rename these three i's to j. So now we have two distinct variables, one variable for add 6, one variable for add 3, and the program is now fixed. End of story. Yep.
And this would be more of a logical error than a mathematical syntax error. So you wouldn't necessarily...
It's a semantic error.
Yeah, no compiler would catch that.
Nope, no compiler would catch it. Now, but what about the solution? I name one variable I name the other one j. That would fix the problem. The question is that type of solution scalable? In other words, when you have two subroutines that are right next to each other, it's easy to see, oh, this one should use I, that one should use j. What about you have 20 subroutines? It gets a little bit difficult, okay, because they won't fit on the same page. And if the subroutines won't fit on the same page, it becomes much more difficult to scan and say, oh, this subroutine is already using that variable as a counter. I should not use it again. So, but I'm smart. I have a way to get around that too. I can just prefix the variable name with the name of the subroutine. So I can name this one add 6 underscore I. I can name the other one add 3 underscore I. So this approach will work with as many subroutines as I have, because as long as the names of the subroutines are unique, so will be the name of the counters. The question is, what happens when I have a little typo mistake somewhere? I copy, paste, and modify, and forgot to change one of the variable names to match the name of the subroutine. Same problem, right? Okay. So that means, when I have global variables, I always have a potential of using a variable where I'm not supposed to use it. Okay? The solution to this problem is actually quite easy. I may not have enough time to actually talk about the mechanism of the solution, but from the perspective of insert row, and it keeps inserting in the wrong page. That is odd. There we go. This time it's right. So all I have to do to fix this problem is to declare that I is now a local variable in both subroutines. In both add 3 and add 6, I will declare I as a local variable. That will fix the problem. And I'll see if I can actually finish a trace in this case. So let's go ahead and try to finish this trace, because it is kind of important to go through this today to make sure that we don't lose track of stuff that we are currently talking about. Okay. Now, adding local I to before line 2 and adding local I to before line 10, I don't even bother to change the line numbers, because local I does not really have anything to execute, and as a result, it is fine without a line number. So the change of behavior is now quite significant. On line 18, we still do the same thing as a regular subroutine. We allocate a column to remember where we're supposed to go back to, and it is still going back to post. That part has not changed. However, for every local variable in the subroutine, we also have to allocate an additional column for the local variable. In this case, we have add 6 has a local variable I, and as a result, we have to allocate a column for local variable I. And the other part is a local variable always starts with an unknown value. Okay, a local variable always starts with an unknown value. That is a very important part, because if anyone forgets about this, this bug will bite you in the C class. Okay, now when we go to the subroutine at 6, we start on line 10. Line 10 is now using column F as as variable I. It is getting a 0. We go to line 11, which is comparing I to 2, and that is true, that I is less than 2. We go to line 12, we invoke subroutine add 3. What is going to happen? Well, we do the usual thing. We say, what is our return line number? The return line number is the logical line after line 12, which is line 13. So this part has not changed compared to the previous example. However, we also allocate one column for each local variable. Add3 has its own local variable I, and as a result, we now use column H for the other local variable I, which also starts with an unknown value of question mark. Yep.
But if you allocate another local variable, don't you not need the first variable I?
Aha, that's a good question too. As it turns out, when we say a variable like I is local to a subroutine, it is local in two senses. It is local in the sense of lexically it is local. In other words, this I here is visible only within add 6. This I here is only visible within add 3. So the first local part has to do with which part of the program can see that variable I. Is that okay so far?
Yeah, but in the trace you still put it on column D an I variable, which is unknown. It seems like you're not going to use it at all.
I will use it later on. I may not have enough time today to trace it, so let me see if how far we can go from here. After we save the return line number, we can go into the subroutine starting on line 2, and line 2 is going to initialize column H, in this case, to 0. You can see that line 2 and line 10 are no longer initializing the same column. They are working on different columns this time. On line 3, I is less than 3 is referring to column H. And that is true. And then we go to line 4. X is incremented from 11 to 12. On line 5, we are talking about column H and not column F. And then we go back to line 3. I is less than 3 is still true. I just want to make sure that we can get up to the point where it makes a difference. Go back to line 3. I is less than 3 is true. We go to line 4. This is now incremented to 14. We go to line 5. I is now incremented to 3. We go back to line 3. I is less than 3 is false. We get out of the loop. We go to line 7. Now this is the first part that we'll actually see a difference. We still have to continue execution on line 13 because the return line number column is still telling me to continue execution on line 13. But when we deallocate the columns, we now have two columns to deallocate. Both column G and column H will be deallocated at the same time. In other words, this is the other aspect of a local variable. The local means it will only start to live when a subroutine is invoked and the local variable dies as soon as the subroutine returns. Yep.
If you invoke the same subroutine in recurring subroutine, each recurring subroutine will have its own local.
That is correct.
That won't interfere with the other.
They would not interfere.
Okay, even though it's the same subroutine.
Yep, because you only use the most recent version or the most recently allocated